Morning, everyone, and welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up number 45 should be on your screen as soon as you log in. Shouldn't take you long. It says compute the standard deviation for the data sample using the shortcut formula. Oh, yes, we got this. And they're giving you 5 datas, 100, 50, 30, 70, and 120. So, log in. Get that done. I'll give you guys, like 3 minutes? Anyways, let's do 5 minutes. 5 minutes. Yes. You will need a calculator. Send a gopher for a calculator. All right, check with the neighbors, see what they got. They should be done by now. And then send that in, please. So we need standard deviation. What'd you get for this, Nick? $1,330. That's the variance. So the standard deviation, 36.5. Hands if you got 36.5. Something close? Yes, that is correct. Send that in, please. Copy the agenda. Warm-up number 45, measures of variation. Today we're back in grouped data. And your home plate for tonight, page 1. Actually, that's not true. It's actually 2 practice problems. That was from last week. Let's go. 2 problems only. Oh, snap. My coffee. Let's go. My dopio. Check it out. Venti cup. I got a triple dopio with 5 stevias, a splash of milk, non-fat, 2% heavy cream, and some powder. $3. Let's go. I'm telling you, it's a hack. So you, when you select your creams, don't put to add cream, put splash. Splash of this, splash of that, and they don't charge you for any of that. Oh, yeah. All right, we good? Let me send that to your screen so that I can move on to the next one. There it is. Once again, it should be 2 problems for your home plate tonight. Copy the code to have access to the home plate, B56AF. B56AF. Today we're going to keep moving because we have a lot to cover and we're moving on. So make sure, stay focused, get your notes ready. So with that said, there's your home plate for tonight. It's only 2 problems, little itty bitty problems. Oh yeah, we got this. Oh yeah, we got this. All right, get a Cornell note ready, please. And our objective for today, I can summarize data and compute the measures of variation. I can summarize data and compute the measures of variation. I can summarize data and compute the measures of variation. However, today we're going to take a little sidestep because now we're going to be dealing with a lot of data or group distribution. So tell your neighbor and remind your neighbor, what is group distribution? What is group distribution? What am I talking about? What is a group distribution? Don't have Anthony E. enlighten us. Group distribution. Anthony E., what is a group distribution? One word. Oh my goodness, one word. Like you guys say, bruh. JJ, one word. Okay, that's the definition for measures of variation, part of it. Group distribution is a table. By now, my goodness. Trying to retrieve that long-term memory. All right, we know the definition. I'm not going to hammer this anymore. We got it by now, yes? All right, however, these I do want to see how much you remember. Without letting your neighbor know, fill in the spaces on your screen, please. Go. 40 seconds. Hurry up, please. Somebody is writing me in this. Wrong class, people. Somebody are sending me essays over here. What's going on? 10, 9, 8, 7, 6, 3, 1. Bam. All right? Yes, central tendency, variation, and we're headed towards position, but like I said, we're still in variation today, and we're moving on hopefully this coming week for the next section. All right. Now, formulas, last week we had a pop party on these, right? I don't need to ask you any of these. You already know them, yeah? And they should look something like this, yeah? Okay, good, because today we're going to add some more. Woo! Let's go. All right. So, let me pause the music in the back. Look up to the screen. So, example cube, without copying this, just pay attention, write your utensils down, look up to the screen, and it reads, the data represents the number of miles that 20 runners ran in a week. Compute the sample variance, sample standard deviation of the frequency distributed data. Now, this is a little different because we haven't computed the standard deviation or the variance given a group distribution. Today's going to be the first day. However, I already walked you through some steps that we need to get there. Watch. Let me trigger your noodle. Ready? Here goes. Pay attention to this question. Talk it over with your neighbor and let them know what would be the next column that you think we should add here. Talk it over with your neighbor. What would be the next column? What would be the next column that we added there? Not tallies, because we already have the frequency. What would be the next column to the right? What did we add in the past? Think about it. Think about it. All right. Looks like Bree's got it. Very good, Bree. Looks like JJ's got it. Mito's got it. Let's go with Mitos. Mitos, what do you think is the next column that we would get there? The midpoint. Hands if you thought of that. Right? Midpoint? That is correct. That would be the next thing to add. Now, think about it. We already have the frequency. We're going to add the midpoint. And then we added one more column after that to find the mean last week. We did that. We found the mean using an extra column. So think about it. There's the frequency. We're going to add the midpoint. We add one more column. Tell your neighbor what would be the last column that we would add. Talk it with your neighbor. Frequency, midpoint, what would be the last column? Last column. Looks like Darian got it. Very good, Darian. All right, let's see. Looks like we remember the last column. Let's go with Jacob. What would be the last column that we added? Close. Very close. What? Think about it. We had frequency. We had midpoint. What would be the last column that we added? Let's see. Looks like Anthony's got it. But let's go with Noah. Noah, what would be the last column? Close. That's the formula. I'm saying a column. Now, it looks like I took about 3 questions. People don't remember. I said the last column was frequency times what? The midpoint. That is correct. That was the last column we added. Is that correct? All right. So we're up to there. Today, we're going to need all that information in order to use a new formula. So before we get to this problem, I want you to copy the new formula for today. Not these. You already have them, the shortcuts. Here's a new shortcut formula. Here's for the variance, and here's for the standard deviation. Copy those. Let me send those to your screen. Copy them in the back of your notebook where the formulas go. And label this sample variance for grouped data. So if this is sample variance, look up. If this is sample variance for grouped data, what do we call this one? Tell your neighbor. Let me repeat that again. If this is sample variance for grouped data, what do we call this last one? Ooh-wee. Sample standard deviation for grouped data. That is correct. Thank you, Julius. All right. So I left that on your screen. I'm going to leave it on your screen so you can finish copying. Those of you following along on YouTube, make sure you copy those. Pause the video. Let's go to the problem. Example Q, and I want you to copy the table and write the formula again on the top right. Copy the table, or should I say the group distribution, and your formula for the variance on the right side. Copy it exactly how it is. I'll give you some time. Copy and go. All right, so once again, you're just copying the group distribution and the formula all the way to the right, because we're going to use that formula for this portion. So we have class, and these are boundaries, yes. Our frequency, and we said we were going to add a column for the what? Midpoint, and a column for the what times what? Frequency times midpoint. That is correct. All right. So let me label this. I'm going to label this X sub M. All right, calculators, calculate. 5.5 plus 10.5 divided by 2, that is 8. Thank you. 10.5 plus 15.5 divided by 2, that is 13. 15.5 plus 20.5 divided by 2, 18. And what do you guys notice the width is up to write those 3? What is the width? 5. That means the next one is 23, Michael Jordan. And then 28. Then 33. And then 38. All right? So the next column in blue, you're going to label frequency times midpoint. All right, calculators calculate. AJ, oh, not here. Darian, 1 times 8, 2 times 13. Pass someone? Martin, 3 times 18. 5 times 23. Pass someone? Jacob, 4 times 28. 3 times 33. And 2 times 38. All right. Not bad, not bad. So far, so good, yes? All right. So now, before we move on, I'm going to stop right there just to see where we're at. And that's where we left off when we had computing the mean and so on and so forth of the group data. So, let me show you the formula. Writing utensils down, look up to the screen. Writing utensils down, look up. Ready? Here it goes. By now, we should be very familiar with all these symbols. We know what S stands for. Is that correct? And why we use the letter S instead of the Greek one. Talk it over to your neighbor. Why do we use that letter S instead of the Greek one, please? All right, looks like Arisai's got it, but let's go with Donna. Why do we use the letter S instead of the Greek? Because it's a sample. That is correct. Yes? And since it has the square, we know this is variance. Yes? So far, so good. We know what the letter N stands for. Yes? Remind your neighbor what the letter N stands for. What does the letter N stand for? Yeah, the number of data. Is that correct? Number of data, in this case, since we have group data, is the numbers that we have for the F times the midpoint. All right. Now, let's look inside the parentheses. Look up. Look up. We know what the capitalized sigma mean. Is that correct? Tell your neighbor what this capitalized sigma means. What does a capitalized sigma mean? Donna, pass someone. Martin, what does a capitalized sigma mean? That is correct. It's the sum. Okay, so far so good. But the sum of what? Let's look at this. What does this say? Frequency times what? Tell your neighbor, frequency times what? Frequency times what? Martin, pass them one. Frequency times what? What does this little... Yeah, what does that mean? Midpoint what? Squared. That is correct. Frequency times midpoint squared. And this portion is just frequency times midpoint. All right, so let's do this together. Y'all ready? Here we go. Let's do frequency times midpoint squared. Let's label that. I'm going to label that in pink. If you want to circle it in red. And we're going to do that right here. Right here. So I want you to label frequency times x sub m squared. All right, so let's write it out. Frequency is 1 times, what is 8 squared? 8 squared is 64. So that gives us 64. Next one, 2 times, what is the midpoint? 13. But squared, what is 13 squared? 13 squared. 169. So 2 times 169. Calculators calculate. $338. 338. That is correct. Next one. 3, which is this one, times the midpoint squared. So what is 18 squared? Come on, calculators. 324. 324. So what is 3 times 324? 972. Then we got 5 times 23 squared. 5 times 23 squared. Who's got 23 squared? 529. And 5 times 529, that gives me 2645. Looks about right. Next one. 4 times 28 squared. 4 times 28 squared. 28 squared. Let's go with Julius. 28 squared. 784. 4 times 784, Julius. 3,136. Then we got 3 times 33 squared. 3 times 33 squared. What is 33 squared? Pass them one. Martin? 1,089. And 3 times 1,089 should be 267. And the last one, 2 times 38 squared. 2 times 38 squared. Pass them one. Vanessa, 38 squared. 1444. 2 times 1444 is 2888. That is correct. All right, but this says they both have what? The Greek symbol sigma, yes? So, everybody, calculators, 64 plus 338 plus 972 plus 2645 plus 3136 plus blah, 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 3267 and 2888. Total. Vanessa, pass them one. Woo! Martin, what'd you get? What's that? Okay, we'll wait for Martin. $13,310. Looks about right. Now that is for this part. Look up for this part. But they also want us to find the sum of the midpoint only. So calculators, find the sum of frequency times midpoint. The blue column. 8 plus 26 plus 54 plus 115 plus 112 plus 99 plus 76 is, Martin, pass them one. Who? Oh, Julius. Yep, just the sum. 490. All right. So, I'm going to label this one in blue so that we know what to substitute where. All right. So now that we have our data here ready, let's get our formula. Here we go. Variance. It's approximately parentheses minus parentheses squared, parentheses minus 1. So, by the way, what is n? Read the problem and tell your neighbor what n stands for. How many total? 20. That's our n. So we're going to write n is 20. Oh, sorry. Let me replace that here. 20. Then we got 20 and 20 minus 1. In here, tell your neighbor what to write in here in the parentheses. And then JJ is going to enlighten us. What do we write in here? Go, JJ. Yes, 13,310. And what do we write on the other one, JJ? Yes, 490. Yeah, it looks very familiar, right? Except for now we're using midpoints for these distribution data. All right, so variance is approximately, let's see, calculus calculate, and JJ is going to pass it to someone so they can help us out. JJ, go. Donna, 20 times 13,310 is 20 times 13,310. 266,200 minus, Donna, what is 490 squared? 24,100. Very good. And 20 times 20 minus 1, which is 19. That's what? 380. All right, not bad. Variance is approximately 266, 200 minus 24, 100. That's, is it 16,100 divided by 380? Oh, no, it's 26,100. 26,100 divided by 380. And our variance is, tell your neighbor what you got for the variance. Variance, sample variance. All right, looks like Jessica's got it. Jessica, what'd you get? 68.68. All right, hands if you got that. All right, so that's the variance, but they also want what? Standard deviation. So find the standard deviation, approximately what? Tell your neighbor what you got. Then Jessica's going to pass someone. All right, looks like Mitos got this. Standard deviation is 8.29. Hands if you got that. And tell your neighbor how we got that number, please. How do we get that number? Yeah, at the end we do what? Square root of the variance to get our standard deviation. All right, let me send you the screen so you can send me your notes. Send that in, please. So if you notice, everything seems very familiar, and it's all computation from once we substitute into our formula. So for data that's grouped like this, from 1 to 5, how comfortable are you with variance and standard deviation? Now with our new formula. 5, 5, 5, 4 is a couple of 3.5s, but I think we just need practice, yes? All right. So tonight's home play, you have one of these. Let me show you the second one. You're like, Mr. Q, that's cool that you give us a table already. Yeah, but what if I don't? So before anything, I just want to make sure that we got this. When you are given raw data, tell your neighbor the first 2 steps that you need. When you are given raw data, what are the first 2 steps? Tell your neighbor, what are they? First 2 steps. Woo, JJ in the house. JJ said, number 1, find the range. That is correct. What is the second step, JJ? The width. That is correct. And once we have that, look up. Don't copy this. I just want to walk you through this. My class limit, we start off with what number? Tell your neighbor, what number do we start off our class limits? What number do we start off our class limits? Let's say I keep giving you different data. What would you say to someone, what would be our first class limit? Everyone? The lowest data. That is correct. Lowest. And then the next number down to the next class is what? The lowest plus what? Tell your neighbor. The lowest plus what? The lowest plus the width. That is correct. And so on and so forth. So from 1 to 5, how comfortable are you with building a group distribution? Let's see, where are we at? 5 4s, 5 4s. Yeah, it's coming back, right? So to not waste any time, I'm going to give you guys the actual home plate for tonight. There's two of them. One's already in the table format, but I want you to start with number 1. I am going to ask you to send me what where you're at in regards to your group right now. I want to make sure that you are following along. There it is on your screen. Start with number 1. It's only 20 data numbers. And notice here on this problem, they don't tell you how many classes. But think about it. If we have 20 data, how many classes would you divide this data to make it a group distribution? Tell your neighbor, how many classes would you divide that into? How many classes? All right. How many classes, Clarissa? 5. Hands, if you agree with 5? Yeah, that is correct. So your class for number 1, you're going to divide by 5 so you can find your width. All right? So get started, and I'm going to ask you to share your work where you're at. Those of you that are following along on YouTube, make sure you get some practice in. See you guys next time. Peace.